Dr. Pariser, and it's March 28th, 2007, and what I'm going to do is show you how to write Maxwell's equations. Now, Maxwell was a physicist in the late 1800s, and Maxwell was the person who discovered that the electric constant and the magnetic constant predicted the speed of light. So Maxwell concluded that light must travel as an electromagnetic wave. The equations involve the electric field and the magnetic field. And what I'm going to do is write the electric field as a capital E, and I'm going to write it down 3 times. And the magnetic field I'm going to write as a capital B 3 times. Now, E stands for the electric field, B stands for the magnetic field. And these equations are integral equations, and so I'm putting an integral over these equations. Now, when you multiply a vector by another vector, you have a dot product. And so there's a dot over here and a dot over here, dot over here, and a dot. Now, the top integrals are Gauss's law, and they're integrals over an area, but a very particular type of area. The area has to be perpendicular to a surface. So they're an integral over an area, and the area has to be perpendicular to the surface. This is an integral over an area, and the perpendicular component. This is Faraday's law, and this integral is over a distance. And this is Ampere's law, and this integral is over a distance. Now there are equal signs here. So there's an equal sign over here, equal sign over here, equals, equals. And over here, there's an equal sign also. Now the Lorentz force is equal to the charge Q multiplied by the electric field, plus the charge Q moving with the velocity v across a magnetic field. This is the Lorentz force. Now over here, this is Gauss's law that says the integral of the electric field crossing the surface is equal to the charge enclosed by that surface divided by the electric constant. And this is Gauss's law for the magnetic field, saying the integral of the magnetic flux is equal to 0. Over here, we have a derivative, and it's negative. And over here, we have a derivative, and it's positive. Now, what goes over here is the magnetic flux. So I'm going to put the magnetic flux over here. And what goes over here is the electric flux. So I'm going to put the electric flux here. To round it out, we have the electric constant, the magnetic constant, multiplied by the current going through the loop divided by the electric constant. Now, these are Maxwell's equations, and this is the Lorentz force. And these equations predict or are used to derive the electromagnetic wave. These equations describe how radio, television, microwave, how all of those signals come to your home through these equations. Maxwell was the one that said that he added this term, which is a displacement current, and these equations became Maxwell's equations. Thank you very much.